Hello everyone, I'm Saptarshi and welcome to the Tech Think Tank. Today we are going to dive into the world of AWS Global Infrastructure. In this video, we will understand what are AZs, regions, edge locations, and regional edge cache. With technology evolving daily, staying up to date and informed is essential. That's where we come in. Our mission is to bring you the latest and greatest in technology and help you understand how it can impact your daily life. So sit back, grab a cup of coffee, and let's get started. This is the fourth episode of the series on Amazon Web Services. If you haven't seen the earlier episodes of this series, please have a look at them. I'll put the link to them in the description, or you can click the pop-up banner now. As a leading public cloud provider, Amazon Web Services requires a robust global infrastructure to deliver and maintain its expanding suite of cloud services, catering to customers worldwide. In this video, we'll explore the essential building blocks of the AWS Global Infrastructure. 1. Availability zones, AZs. 2. Regions. 3. Edge locations. 4. Regional edge caches. Whether you're a seasoned AWS user or just starting out, it's crucial to grasp the role of each component in the AWS Global Infrastructure, their interdependencies, and how they can be leveraged to optimize your solution. Let's delve deeper into each of them. Availability zones and regions are closely intertwined in the AWS Global Infrastructure. AZs represent the physical data centers where AWS hosts its compute, storage, network, and database resources, which we as consumers can provision in our virtual private clouds, VPCs. However, it's important to note that an AZ may consist of multiple data centers located in close proximity, rather than a single one, as commonly believed. Each AZ is linked with at least one other AZ located within the same geographic area, often a city, through highly resilient and low-latency private fiber optic connections. However, each AZ remains isolated from others by separate power and network connectivity to minimize the impact of a single AZ failure on others. AWS services use these low-latency links between AZs to replicate data for high availability and resilience. For example, RDS, Relational Database Service, leverages synchronous replication between primary and secondary databases and asynchronous replication for RED replicas in a multi-AZ deployment. Multiple AZs, typically 3 to 5, linked via these low-latency connections within a geographic area, define an AWS region. Using resources across multiple AZs in a region helps create highly available and resilient applications and services. By architecting solutions to distribute resources across more than one AZ, minimal or no impact will occur to infrastructure if an AZ fails, which can happen. While anyone can deploy resources in the cloud, designing them for stability, availability, and resilience during a disaster requires careful architecture. Leveraging at least 2 AZs within a region is a recommended best practice to maintain high availability of infrastructure.
As we have learned, a region is a group of availability zones that are located close to each other geographically, typically within the same city. AWS has deployed these regions globally to offer its customers around the world low-latency connections. Each region operates independently of the others and consists of at least 3 availability zones. For instance, if a London-based organization was serving customers throughout Europe, deploying services in the Sydney region would not be logical due to the high latency response times for its customers. Instead, the company would select the most appropriate region for its customer base, which may be the London, Frankfurt, or Ireland region. Having multiple global regions also enables compliance with data storage regulations, laws, and governance at rest and in transit. For example, if you are required to keep all data within Europe, multiple regions within this location allow you to meet this requirement. Just as utilizing multiple AZs within a region results in high availability, the same can be applied to multiple regions. Depending on the level of business continuity needed, you may choose to design your AWS environment to support your applications and services across multiple regions in case an entire region becomes unavailable due to a natural disaster. You may require multiple regions if you are a global organization serving customers in different countries with specific data use laws and governance. In this scenario, you could connect different VPCs together in various regions. AWS is working to keep up with the demand for cloud computing services, and the number of regions is increasing every year. At the time of creating this video, there are 20 regions and 61 availability zones, with 4 additional regions and 12 AZs planned. It's worth noting that not all AWS services are available in each region, which is a consideration when designing your infrastructure. Some services are global, like AWS Identity and Access Management, IAM, or Amazon CloudFront, which are not associated with a particular region. However, most services are region-specific, so you must know which services are available in which region. Each region operates independently of others, and AWS GovCloud is a unique region in the U.S. only accessible to U.S. government agencies and organizations in government-regulated industries that meet strict requirements.
AWS employs a specific naming convention for its regions and availability zones. Depending on the context, a region can be referred to by 2 different names. A region has a friendly name that denotes its location, which can be viewed within the management console. It also has a code name that is used when referencing the region programmatically, such as when utilizing the AWS CLI. The first column provides a more user-friendly name compared to the code name, as it is easier to associate with a location. However, availability zones are always referenced by their code name, which is defined by the region code name of the AZs that they belong to, followed by a letter. For instance, the AZs within the EU West 1 region, EU Ireland, have the following code names. 1. EU West 1A. 2. EU West 1B. 3. EU West 1C. An interesting point to be aware of here is that AWS maps these AZ letter identifiers to different physical AZs for different AWS accounts. This ensures that there is a more even distribution of resources across all AZs within a region. If you have multiple AWS accounts and you try to coordinate resources within the same AZ by selecting the same AZ code name, this may not necessarily mean that those resources are physically located within the same AZ, as you can see in the image above.
Edge locations are strategically placed AWS sites located in major cities and highly populated areas across the globe. They vastly outnumber the availability zones. While they aren't intended to host your main infrastructures like EC2 instances, EBS storage, VPCs, or RDS resources, edge locations are utilized by AWS services such as Amazon CloudFront and AWS Lambda at edge to cache data and minimize latency for end users by leveraging the edge locations as a global content delivery network, CDN. Therefore, edge locations are mainly used by end users who access and utilize your services. For instance, if you're hosting your website on EC2 instances and S3, your origin, within the Ohio region and have a configured CloudFront distribution associated, when a user accesses your website from Europe, they'll be directed to their nearest edge location, in Europe, where cached data could be read from your website, significantly reducing latency.
In November 2016, AWS introduced a new type of edge location known as a regional edge cache. These caches are positioned between your CloudFront origin servers and the edge locations. Compared to individual edge locations, a regional edge cache has a broader cache width, and since data expires from the cache at the edge locations, the data is preserved at the regional edge caches. This means that when data is requested at an edge location where it is no longer available, the edge location can fetch the cache data from the regional edge cache, avoiding the origin servers and their higher latency. Thank you for watching this video on AWS Global Infrastructure. We hope you found it informative and gained a better understanding of how AWS regions, availability zones, and edge locations work together to create a reliable and efficient cloud computing platform. As always, don't forget to like, comment, and subscribe to the Tech Think Tank for more informative tech content. And if you have any questions or suggestions, feel free to leave them in the comments below. Stay tuned for our next video, where we'll be discussing another exciting topic in the world of technology. Until next time, stay curious and keep exploring the world of technology.